Travis Gillespie here. I'm going to work with some solving absolute value inequalities, dealing with the greater than symbol. So let's look at the absolute value of x plus 5 is greater than 14. You know, when dealing with absolute value inequalities, you want to isolate the absolute value. So the way to undo addition is with subtraction. These guys cancel, and you end up with the absolute value of x greater than 9. Once you get to this point, since 5 is added to the absolute value of x, and we've subtracted it, right? Once we get down to this point right here, the thing you want to think is the distance from x to 0 is greater than 9 units. So the distance from x to 0, it's greater than 9 units. All right, so let's draw our number line up. Ooh, boy, I'm going to fix that. Let's do... I'm just drawing up my number line. I'm going to say I'm going to jump these by 3 units apiece. So 3, 6, 9, 12, negative 3, negative 6, negative 9, negative 12. All right, so the thing that we're thinking, the distance from x to 0, it's greater than 9 units. Well, I got a positive 9 here, so I really have two different cases for the absolute value of x. X is greater than 9, or x is greater than negative 9. So let's go ahead and plot these up. And I have an open circle on both points. And what I'm saying here, the distance from x to 0, it's got to be any value greater than 9 units. So really, I'm going to go to 9 units away from 0, and my line is going to go in a positive direction. Then I'm going to redraw my arrows going, hey, that's where my values of x are going to be. Or they're also going to go at 9 units away from 0 in the negative direction, and the units are greater than 9 units. X is greater than 9 units, also in the negative direction. But let me draw up one more portion to this graph so you can see what I'm talking about. Think that x is x to 0, wherever x is on this number line, and its reference to 0, the distance has got to be greater than 9 units. So what I'm saying is that the distance from x to 0, again, is greater than 9 units. Well, this is 9 units apart from 0. Or a better way to say that, this distance right here is 9 units. So x is greater than that portion. Also, this distance is 9 units. So x is going to be a greater value of 9 units in this direction. Okay, once I get here, I'm going to write this graph as a compound inequality. So the first value I see is negative 9. Well, I want to look at where this arrow is heading. It's heading in a negative direction from negative 9. So the values of x are actually getting smaller. So I know that negative 9 is greater than x. Or another way to say this is x is less than negative 9. Now let's go ahead and look at the other side. And I'm going to say, hey, starting with positive 9, x is moving in a more positive direction. The values of x are getting larger. So 9 is less than x, or x is greater than 9. So the way that you would read this entire compound inequality is x is less than negative 9, or x is greater than positive 9. So x is less than negative 9, or x is greater than 9. And Let's go ahead and box my solution here, if I can get a straight enough line. There's my answer. X is less than -9 or X is greater than 9. Let's look at another problem. So let's look at the absolute value of X minus 20. Make that a little bit cleaner for you guys. Minus 20 is greater than 13. Again, you want to isolate the absolute value. So undo subtraction with addition. You end up with the absolute value of X is greater than 33. So from this point, the next thing that you want to do is you want to think, hey, the distance from X to 0 is greater than 33 units. The distance from X to 0 is greater than 33 units. So let's go ahead and draw this up on the number line. I'm going to change colors here. And here's 0. And let's do this. Let's do a mark here, a mark here, and a mark here. I'll do some more plots here. All right, I'm just drawing my arrow. It really doesn't matter what numbers I throw up on the number line as long as I know which direction's negative and which number direction's positive, and I'm consistent. So I'm going to say these are -15, -30. I'm jumping up by multiples, or I should say I'm jumping up by values of 15. So 45. Oh, so negative, let's rewrite these. -45, -30, -15, 0, 15, 30, 45. All right. So again, the thing you think is the distance from X to 0, wherever X is on this number line, it is greater than 33 units. The distance from X to 0 is greater than 33 units. So what I'm going to do, change the size of my pen, change the color. Let's go ahead and plot this. Well, it's just greater than, it's not equal to. So I would say 33 is probably close to, it's going to be real close to 30, but it's not going to touch it. So let's just say it's here. It's not it's just a real educated guess, a good guess. And the circles are not closed. They're open because the value does not actually equal 33. It's greater than 33 units away from 0. So I know that this point here from 0, the value of that, this is a distance of 33 units. And also on the other side, this distance from 0, 33 units. But X is greater than 33 units. So I know that when I go to draw this on the graph, my values are moving in a direction greater than 33 units. Okay, so now I can write up my compound inequality. And it's going to say, hey, here is -33. That's an easy point to start at. So -33, X is less than, it's moving in a direction that's less than, so x is less than negative 33. It's not equal to. So x is less than negative 33, or x is greater than positive 33.